Yeah, thanks, Yanshan, for coming to MiCHAMP.
So hello, everyone. Our speaker today is Dr. Yanshan Wang. Dr. Wang is the Vice Chair of Research and Assistant Professor with a primary appointment in the Department of Health Information Management and secondary appointments in Intelligent Systems Program, Department of Biomedical Informatics, Clinical and Translational Science Institute, and UPMC Hillman Cancer Center at the University of Pittsburgh. He has over 10 years of research experience in AI, natural language processing, and machine learning methods and applications in healthcare. Dr. Wang's research goal is to leverage different dimensions of data and data-driven computational approaches to meet the needs of clinicians, researchers, and patients. Hey, Yanshan, you can thank you, and you can take it from here.
Thank you, Xiaoxi. Thank you for the kind introduction. So I'm very fortunate to give this presentation and also very humbled to give this presentation on the clinical natural language processing, how ChatGPT will fundamentally change the game. Because ChatGPT is a hot topic right now. And as an insider, we definitely know how ChatGPT is a breakthrough technology. And through this talk, I will talk about some traditional technology in clinical natural language processing and why ChatGPT could be a game changer. So I have no financial disclosure or conflict of interest with the presented materials in this presentation. So since its launch in November 2022, ChatGPT has captured almost everyone's attention. So ChatGPT is a chatbot developed by OpenAI, and it actually has millions of users around the globe and showed extraordinary potential of artificial intelligence. Not like those chatbots released before, ChatGPT can draft letters, compose poetry, copywriting, answer questions with very promising results. So as an NLP researcher in the medical and clinical domain, we are not unfamiliar to ChatGPT and the model behind it, which is the GPT-3. So my lab actually focused on the biomedical and clinical NLP and has done a lot of research on how to tune those large language models for clinical and medical tasks. And we envision that this new technology will be a new game changer in the clinical NLP field, but we just didn't expect that it comes so fast. So in this talk, I will briefly overview the clinical NLP problems and then introduce some traditional clinical NLP techniques that have been quite successful in the domain. And then I will talk about the new paradigm that ChatGPT brought to the clinical NLP domain and similar large language models that we have been researching on in my lab for the clinical NLP. So we all know that the healthcare system have widely adopted electronic health record system since the HITECH Act was signed into the law in 2009. So the size of the EHR data has increased dramatically in the past decade. So as you may know, the original use of the EHR is to facilitate capturing patient and clinical data and sharing such data with different covered entities. So later, healthcare system realized that the use of the EHR data could make the clinical workflow more efficient and more effective. So therefore, those EHR data has been used to advance the clinical process. And with a large amount of EHR data collected every day in those healthcare systems, and people have to start to think about the secondary use of the EHR data in the clinical and translational research, and of course, ultimately, how to use the data to improve healthcare outcomes. So however, the reality of the EHR is that 80% of the useful information is embedded in the unstructured format. So for example, the clinical notes, radiology reports, pathology reports, and only 20% of the useful information is embedded in the structured format, such as the demographics, diagnosis code, lab results, medications. And the purpose of those structured data is to facilitate administration and billing. So they have several limitations for research and for improving the healthcare outcome. Along with the unstructured EHR data, there are a lot of knowledge information in the biomedical literature. So all those biomedical literature data are also in the free text format. So they contain most updated knowledge for healthcare systems and even the pharmaceutical companies to make decisions and conduct research. A large amount of the information in this textual data, of course, is much more useful for research and for the healthcare improvement. So that's why natural language processing, or NLP, is a key technology to uncover those information embedded in unstructured EHR and the biomedical literature. And use that information, we could deliver better healthcare and we can advance the clinical and the translational research. So what is NLP? So based on the Wikipedia, NLP is a subfield of computer science, information engineering, and artificial intelligence, concerned with the interaction between computers and human language, and in particular, how to program computers to process and analyze large amount of natural language data. So NLP is an interdisciplinary domain that combines computer science, information science, and artificial intelligence. And some people even believe that NLP is an AI complete problem. So NLP does not only process the natural language data, but also analyze the data and extract the nuance from the language data. NLP contains many different subtexts. So in the following, I will introduce several examples of the different NLP subtexts. So question answering is an NLP subtext that is concerned with building an NLP system to automatically answer questions posed by humans. So we all know that IBM Watson is an automated question answering system, and it competed against Java's two great champions in 2011. And we are using those question answering systems every day through those voice assistants like Apple Siri, Microsoft Cortana, Amazon Alexa, Google Assistant, to name a few. So in a question answering task, researchers are usually given a graph of context and questions and need to construct answers based on the given context. Sometimes the contexts are not given, and researchers need to build models to construct answers based on the information from public domain. So such as the MedQuil AD dataset, they use NIH website as a context domain, and the researcher need to use all those public available information to answer that question. So in one of our papers listed here, we actually developed an NLP model to automatically answer COVID-related questions at the beginning of the pandemic. And ChatGPT actually can also be considered as a question answering system because it generates answers to an input question. However, it is quite different from the traditional question answering system. So because it didn't need the context. So I will discuss that difference later. Information extraction is another subtext in NLP. It contains several specific small tasks in this domain. So for example, we want to extract family history information from this given clinical note. So the first step in information extraction is called name entity recognition, or NER. So NER seeks to locate and classify name entity mentioned in the unstructured text and classify them into some predefined categories. So in our example, family members, conditions, age information, those are some predetermined categories, and we need to classify those entities into one of those categories. And it is usually followed by name entity normalization, which assign those predefined identifier to the recognized entities. So after NER, we need to figure out the relation between those entities. So for example, in this case, the age of 50 is associated with this breast cancer, and age of 80 is associated with pathway, the living status. So we have to figure out what is the relation between those entities. For human being, it is quite straightforward after reading the note, but for machine, we need to teach them how to identify those relations. So relation extraction is a task of predicting the relations for the entities in the sentence. And after the relation extraction, people sometimes also build a graph to represent the family history information for the patient. And using this graph, we can have a bigger picture of the family history of different family members and different conditions. And we may need to consider different approach for every step. And for name entity recognition, we may use different machine learning models. And for relation extraction, we may use different, classification models. And we also need to use different training data for those different extraction tasks. So sentiment analysis is another NLP task that tries to use NLP to systematically identify, extract, quantify, and study the affective states and the subjective information. So in healthcare, sentiment analysis is often used to help healthcare systems to monitor brand and product sentiment in the patient feedback. So for example, whenever we want to identify some, family physician, we go to the healthcare system website and check the review for those physicians. So in addition to, some attributes of every physician, we also check whether there are more positive reviews or negative reviews. And those reviews will impact our decision which physician we want to choose as our family doctor. So text summarization is another NLP task that involves the process of shortening text computationally and to create a summary that represents the most important but relevant information within the original content. So this example shows a use case in clinical area for radiology report summarization. So it could accelerate the radiology workflow and improve the efficiency of the clinical communication and clinical documentation. So those are some concrete NLP subtasks. As you see here, there are also many other NLP tasks. So here is just a subset of different NLP tasks. And for each NLP task, we usually need to use specific training data, testing data, and build specific models for that specific task. So NLP researchers label ourselves as experts for different NLP tasks and study different approach for this task. For example, for myself, I usually label myself as expert in the information extraction, name entity recognition, text classification. And I rarely touch, for example, relation extraction, sentiment analysis, or text summarization, because the technology behind those different tasks is quite different. So there are three mainstream paradigms regarding different NLP approach. Symbolic NLP, which is developed up to 1980s, use a comprehensive set of rules and keyword-based features to identify some predefined pattern in the text. So that's why it is also called rule-based NLP. So around 2000, statistical NLP, statistical machine learning models, such as some random forest, support vector machine, LDA, latent directly allocation, those kind of models become popular, and they were applied to solve NLP problems. Artificial neural network were also used to solve NLP problems. But since the training neural network requires so much computing power, it wasn't popular until the GPU was widely available that researchers have access to. And later, recurrent neural networks like RNA and LSTM, long short-term memories, those are used to take sequence of text data into the training process. And transformer models were introduced in 2017 by a team at Google Brain. And it's becoming increasingly, the choice of NLP task. And it starts to replace RNN models and become the new paradigm in NLP. Because those transformer models can leverage transfer learning mechanism, that the model were trained with large language data, such as all the Wikipedia corpus. And then using those language data, they can be further fine-tuned for specific NLP tasks. So therefore, they have a much better performance compared to the traditional deep learning models like RNA. So let's take a look at those rule-based NLP first. So here is an example how we use rule-based NLP for the clinical notes. So in this example, we have several sentences from the clinical notes, and our goal is to identify the gene mutation from the clinical notes. And this type of information is usually only available in the clinical note or the genetic report. So that's why we need NLP to help us. So the first step in the rule-based NLP It's called a sentence detection. So we need to detect different sentences in this clinical note. And after detecting those sentences, we need to tokenize the sentence, every sentence, into different words. So for English, tokenization is quite straightforward because those words are split by either space or punctuations. But for a lot of other language, like East Asian language, like Japanese, Korean, or Chinese, those words are not, there's no space between those words. So tokenization might be a challenging problem for those language. So after tokenization, we need to identify the concept from the given sentence. So in this case, P53, which is a gene mutation, is something that we are interested. And after concept identification, we need to do assertion on this concept. So it is not uncommon that in the clinical notes, there are a lot of negations or hypothetical mention of the notes. For example, the patient might have some disease, right? So this type of mention is called hypothetical mention, or the patient did not have a history of diabetes. So this is called a negation concept. So we need to identify those negation and hypothetical concepts and do the assertion on the concepts. And then we need to apply several rules to extract the concept. And because there are a lot of different morphological changes of how the words were used in the clinical notes, we need to use different rules to extract those words. And usually those rules are used in combination with those regular expressions. And eventually we extract the concept as well as whether it's possible or the certainty of the concept, and then do the evaluation. So as you see here, developing the rules in this approach could be really time-consuming and need a lot of knowledge engineering by NLP experts. But based on the literature review, clinical NLP has been dominated by this rule-based approach because of their interpretability to clinicians and their low computing resource requirement. So not every hospital have access to large cluster of GPUs, right? So my team has also developed many rule-based NLP systems for different NLP problems. So here are some published work that has been quite successful. We developed for the different clinical problems. So in this work, we try to extract the fracture information from the radiology report, and the fracture information, including the type of the fracture, like the location of the fracture, the severity of the fracture, all those type of information are not available in this structured data. So that's why we need to extract that information and then provide that information to the physician. So traditionally, those type of information was done by chart review before the patient come to the clinic. So using this kind of NLP system, we can do that automatically and populate those information before the patient come to the clinic in a much efficient way. So as you see here, we have, in this example, we consider around 20 fracture locations. And for each fracture location, we need to carefully design the specific rule to extract that information. So every rule here is, written in a regular expression format. And it takes a lot of time to write those kind of rules. And also for each type of fracture, we need to annotate different data to train those algorithms, and then of course to test the algorithms. And annotation is also very time consuming. So this is another example we did for extracting the family history from the clinical notes, because family history is a risk factor for many diseases like cancers, right? So we need to extract those family history from the clinical notes. And because clinical notes are written in different ways, so the family history could be in a semi-structured format like this, or it could be totally free text, written or dictated by the physician. So that's why for different type of notes, we need to consider different rules and different, design different rules to extract those family history. It is a very, again, it is very labor-intensive work. And we also developed some NLP algorithm to extract lung cancer information related to lung cancer, like the stage of the lung cancer, the tumor grade, chemotherapy, outcome of those chemotherapy. So all those type of information are embedded in clinical notes, and we need to develop specific NLP algorithm to extract that. And we also considered, lifestyle, different lifestyles of the patient because of the recent, interest in social determinants of health. So social determinants of health related to the environment the patient living in, the social economic status, the education, the community the patient living, right? So all those type of factors impact the healthcare outcomes, and also those factors are important risk factors for a lot of disease like mental health disorders or those chronic disease. And we develop different NLP system to extract those different social determinants of health. And one advantage of the rule-based NLP approach is that the clinical NLP community has developed several high-throughput systems to embed the tool in the clinical data infrastructure to efficiently populate those extracted concepts to the clinical data warehouse that are immediately available for researchers and providers. So for example, our OHNLP, the Open Health Natural Language Processing Consortium, has worked together and developed this NLP as a service tool to extract valuable information from unstructured EHR. And it could be run in those clinical data infrastructure near real time. So this will benefit clinical decision-making, administration, reporting, and also clinical and translational research.
Can I add a comment here to the last slide? So
yes.
we also use this system, and Yanshan might remember before you left. So we use the system to screen hundreds of thousands of patients for the eligibility for clinical trials. And then we can use this system to select eligible patients, and then we send them study invitation and ask them to confirm their eligibility for the trial. So I think the advantage to us is just can be run on large population near real time, as Yanshan said. And Yanshan did a foundational work to enable our digital trials.
Thank you for the comment. So we also work with the Odyssey NLP working group to implement NLP systems in the Odyssey OMOP combinated model pipeline to populate those concepts extracted come from clinical notes and following the Odyssey data standards. So for those who don't know what is Odyssey OMOP CDM, so Odyssey is short for Observational Health Data Sciences and Informatics, and OMOP is short for the Observational Medical Outcomes Partnership. So this is Odyssey OMOP CDM is a standardized data model for organizing and representing the observational health data from various EHR sources, not just EHR sources. It could include EHR claims data, registry data, and other observational data set. So the Odyssey OMOP CDM provide a common framework for integrating and analyzing the data from those different resources. So here we can execute any NLP systems to process the text notes in the note table in the OMOP's common data model, and then convert the NLP system output into the notes NLP table in the common data model. Most NLP systems are rule-based approach in this pipeline, and many clinical and translational researchers have started to explore the use of those extracted concepts for real-world research. And in the pharmaceutical domain, a lot of researchers have used this as a real-world evidence to provide insights for their research. And this is the first paradigm in clinical NLP that focused on the rule-based NLP and focus on those, knowledge-based NLP, but still it is widely used in the clinical area. So the second paradigm.
Before you move on the second section, there is a question in the chat saying about the last slide. How do you deal with the words that are not part of the OMOP vocabulary? So usually we select the most the closest word in the OMOP vocabulary to represent the word. And if the word is or the concept, we usually use the word concept. If the concept is not available in the OMOP vocabulary, we can add additional, supplement into the vocabulary.
So your local, you can use that as a local implementation of those for those, concepts. Okay. So, okay, any other questions? Okay, good. So the second paradigm in NLP is around statistical machine learning and deep learning models. So here I want to mention that deep learning models are referred to basically those deep neural network for classification tasks. So that were proposed, prior to the transformer language model. So although those language model, like transformer language model, they are also deep learning algorithms, but here I try to distinguish them when I talk about the second paradigm. So statistical machine learning usually take structured data as input. So where those data can formulate it as rows and columns, where the rows represent data samples and the columns represent features or variables. So however, text data are not structured data. So therefore, in the statistical machine learning NLP approach, we need to convert the text data into language features, such as the number of words, the part of speech of the word, term frequency, or TF-IDF, term frequency inverse document frequency. So those are some commonly used language features we use to represent original text data. So these language features serve as different columns, and they are used as input to the machine learning model for different downstream tasks, such as classification, sentiment analysis, information extraction. So building those language features require some human intelligence, because sometimes we need to select what features should work better for what NLP tasks. So that's usually called feature extraction and feature selection. So deep learning model try to learn these features automatically so that the learned feature could embed as much semantic meaning as possible in the original text data. So that is why deep learning is also called representation learning, because it tries to learn the best representation of the text. So the representation is usually in a vector format. So that is, each word is represented by a vector. So the representation is sometimes called word embedding or semantic representation. And the early deep learning models, such as Word2Vec, GloVe, or Sable, which are proposed around 2012 or 2013, are all fall into this category. And my paper listed here actually compared these models for the performance of these models for clinical and biomedical NLP. So this is a typical clinical NLP pipeline that uses machine learning and deep learning. So we first extract the clinical notes from the clinical data warehouse. We annotate those notes to create a gold standard data set, and then split the data set into training and testing, and to train the machine learning models and then test the performance of those machine learning or deep learning models. So nowadays, the Word2Vec approach was described as outdated already. So with the transformer models being regarded as a state of art in NLP. Transformer models were introduced in 2017 by a paper from Google. The paper was attention is all you need. So transformer model adopt self-attention mechanisms to differentially weight the significant words in the input natural language for a specific NLP task. So because of the use of self-attention blocks in the neural networks, in the encoder, decoder, so the language model becomes larger and larger in terms of parameters that need to be learned. So that leads to the wide use of transfer learning in NLP, which is a third paradigm for NLP. So everyone has a problem, but not everyone has data and the computing power to train the large language models. So transfer learning focuses on storing the knowledge learned from a large corpus, such as Wikipedia and all the text data in the internet, and train a model in an unsupervised way, and then apply the model to a related but not a much more specific text. So it's very similar, to how human being learns. So we start from elementary school to middle school, we learn the basic knowledge, and also in high school, learn the basic knowledge. But once we enter the college, we start to focus on the specific task, right? Specific major. So actually transfer learning mimic that process. So the first step is called pre-training those language model. And the second step is called fine-tuning. And applying the knowledge from the pre-trained model could help reduce training time and take the learned parameters to solve a specific task. So that will allow your model fine-tune from a very better starting point. And models such as Elmo, BERT, BioBERT, they are all pre-trained language models that are available for fine-tuning for specific tasks. And of course, another major reason of using transfer learning is that not everyone has the computing power to train their own pre-train their own models from scratch. So this is a previous pipeline using machine learning and deep learning, and now this is the updated pipeline for clinical NLP. So we take the pre-trained language model that are off-shelf, that are already trained by big companies or big group, and use a small set of annotated data to fine-tune the language model for our specific tasks. So, and there are also a lot of variants of different language models, like BioBERT, which is trained from the medical literature, and the clinical BioBERT is pre-trained, it is trained on the MiMIC dataset. So here I listed a few papers that my team has published and used this approach for different clinical NLP tasks that include detection of major depressive disorder, sleep information from the clinical notes. So as a number of parameters, yeah.
Can I ask a quick question?
Yeah, sure.
When you talk about the pre-trained large language models, and I know you're getting to them, just for many of us who aren't like in the space deeply, like, is there anything like methodologically new about those approaches, or is it really just the size? Like, it's just they dumped all of Wikipedia into it, and so that's where the magic happened. I mean, because there was clearly like you introduced it like a jump step forward in terms of the responsiveness of these new models. And I'm just curious, or is there something in this transformers that is like fundamentally different?
Yes, so there is something different in the architecture of the natural language model. So earlier I mentioned the self-attention block, so which is a block that designed in the architecture, and there are several other blocks that are not available in the traditional deep learning model. It's like you build a giant building, right? When you design the building, everyone may design the building differently, and there's no theory, which block or which architecture works better, but there is definitely some significant difference, and there is some art out there in the architecture. Hope I answer your question.
Yeah, no, thank you.
Okay, and as the number of parameters in the in the language model becomes larger, so this language model becomes larger and larger, and the so-called large language models. So BERT-based language model has 110 million parameters, and BERT large has 340 million parameters. GPT-3, so which is believed as the base model that ChatGPT was built from, has 175 billion parameters. So by learning from billions of natural language text from the internet, those large language models start to learn better language grammar and the fact about our word, the reasoning about our word, the logics about our word, and particularly the text generated by those GPT models becomes more promising. So this leads to a new paradigm in NLP, so which is called the generative NLP era. So the exact date of generative NLP is unknown, but I believe it started from the born of GPT models. So the success of ChatGPT has brought those generative AI and NLP model to people's attention again. So generative AI is not new. It is an unsupervised learning for creating new content, including like images, videos, text, audios, and even programming code. So far there are two main framework of generative AI, the so-called GAN, Generative Adversarial Network, and GPT, Generative Pre-trained Transformers. A famous example about GAN is that it can generate some fake face images that look like celebrities, but they're fake. And GPT is developed by OpenAI. It is an autoregressive language model trained on the data available on the internet. So giving an initial text as a prompt, it will produce a text that continue the prompt. So there have been 3 versions of GPT, GPT-1, GPT-2, and GPT-3. And ChatGPT is believed to be built on the GPT 3.5, so which is a fine-tuned version of GPT-3 for question answering. And DALL-E 1 and 2 is another generative AI, which is a text-to-image generative AI system developed by OpenAI. So it can combine concepts in the text to generate more realistic images at very high resolution. And DALL-E's model actually is actually use the GPT-3 model and trained on text-to-image pairs from the internet. And OpenAI believes that at the beginning, believes that those generative AI models will provide creative solutions for almost all machine learning problems and realize the dream of artificial general intelligence, or the AGI. So now comes to today's topic.
Before you move on, there is a question in the chat regarding how is a parameter defined.
So let me tell you. So for example, if you learn a linear regression, you need to learn the parameter, the slope, and those parameters for linear regression, right? So in deep learning, it's similarly, there are a lot of weights for the neural network. So those weights are called parameters.
There is another question in the chat. How do you source your anonymized medical information training data?
Source.
So or do you want the participant to elaborate more?
Just basically, like, a lot of that data is extremely sensitive, the training data. I was just wondering, like, how do you get it?
I will talk about that later. Just
Sure.
hold this question.
Yeah. Okay.
A second. Yeah. So why ChatGPT? Why we believe the generative large language models like ChatGPT will be a game changer for the clinical and biomedical NLP. So let's go back to this figure again. So in my previous slide, I talk about different tasks in clinical NLP: information extraction, name entity recognition, relation extraction, text summarization, and to name a few, right? So we need to develop different approach, annotate different data for different clinical NLP tasks, such as fracture detection, family history extraction, cancer type identification. We have many papers in those different domains. And those annotation and algorithm development may take several months to almost 1 or 2 years. So they are very time consuming and also require a lot of resources. So in the following example, I will show you how ChatGPT will tackle this clinical NLP task and show you why it could be a game changer. So this example shows how I use ChatGPT for clinical name entity recognition. So on the left example is family history extraction. So by using the prompt, extract the family member and family condition from the following note, ChatGPT is able to extract the family member with associated age and condition. So here, just for your information, the note here is from empty sample that are not a note from our institution. Okay, so because I cannot put notes from our institution there. So the right example shows the phenotype extraction. ChatGPT could identify the phenotypes mentioned in this note. So by using this prompt, extract phenotypes from the following note. Okay, so if you carefully design your prompt, the output will become more computable. So for example, you can ask the ChatGPT to generate output in JSON file or CSV file that is more computable for downstream analysis. So this is another example of ChatGPT for clinical relation extraction. So here I try to identify drug names and extract drug-drug interaction from the given text. So this example comes from the SAMEVO 2013 DDI extraction share task, and those texts come from the biomedical literature. So by designing this prompt, ChatGPT will be able to identify drug names and drug-drug interaction from the given text. So ChatGPT could also be used for clinical note de-identification, which is usually viewed as a name entity recognition task. And again, here I made up this note, so this is not a real clinical note. So as you see here, the ChatGPT could not just identify the PHI information, but also really de-identify the note and generate the de-identified notes, right? And this is an example for clinical text summarization. So in the left figure, the text generated by ChatGPT keeps the semantic meaning, but I try to ask ChatGPT to summarize this note, and this note comes from empty samples. So in this example, ChatGPT could generate some summarized, but it's not very short, right? Still very lengthy and not very summarized. But I changed my prompt in the right figure into the summarize the following note within 20 words. And then ChatGPT could generate a much shorter but more summarized text. So using ChatGPT, we can solve all the previous mentioned clinical NLP tasks. So we don't need to develop different approach for different tasks. We don't need to annotate different data. So maybe we still need to annotate some data for evaluation, but we don't need to annotate data for training the model, right? So that's why all those different NLP tasks becomes one task, which is language generation. So the ultimate goal, which is the ultimate goal of generative NLP, to generate language. And the powerful large language model could fit all different tasks. As an NLP researcher, I know that the game changer has already come. And now all we need to do is to write the proper prompt to teach the model how to generate the output. So of course, there's no doubt prompt engineering will be critical to fully release the power of large language models. And obviously, there are already people realizing that it could be a good business to start with. And now the question becomes, are we prepared for the paradigm shift from the previous model training to this generative AI? So before the launch of ChatGPT last year, my lab actually has done some work to investigate the use of prompt and large language models for clinical NLP. So here I want to briefly introduce them because of the time limit. The first work was done by my student Sanish, where we investigate the use of prompt-based zero-shot learning for clinical NLP. So we tested different types of prompt on a mimic phenotype identification task. And we tested several different large language models. If you are interested, you can read the papers here. And the second work is done by David Onani in my team, where we propose to use Siamese neural network in a few-shot setting. So the few-shot setting is that we only have a few training samples with supervised information. And we hope that the large language model could be fine-tuned from those examples, or at least try to learn to adapt to the specific task from those few examples. And here's the paper, you can read the details. So last but not least, I want to talk about a few challenges using generative NLP, like ChatGPT for clinical NLP and biomedical NLP. So because this is an emerging field, and that it's just 2 months when the ChatGPT was released, so those challenges may not be a complete list. So GPT models are not trained on the large real clinical nodes. So that's why the GPT model may have limited ability in capturing language characteristics in clinical nodes. And right now, both GPT-3 and the ChatGPT are not released publicly and only available through the OpenAI API. So if you want to use their own model, you have to upload your text to their server to process and generate the answer. And we all know that the clinical notes may contain PHI information, and HIPAA may prohibit the use of such models. And somebody may want to, first, can I de-identify the clinical notes and then use the OpenAI service? But the de-identification by any software is not 100% accurate. And for research, you may still need to educate your institutional IRB why this could work, and they may easily say no. Another potential way to create is to create some HIPAA-compliant local OpenAI server for those models and for every specific institution. But this is associated with very high cost, and I'm not sure if that works or not. So some challenges with ChatGPT itself include the prompt injection. So prompt injection is a technique they use in NLP to fine-tune the pre-trained language model to perform some specific task or generate a specific type of text. So the idea behind the prompt injection is to provide the language model with a pre-written prompt or the template that guide the output. So by injecting an idea into the language model, it can be trained to produce more accurate and relevant response to a specific task. But of course, it could also mislead the language model and generate more misinformation. And a prompt injection attack is related to the privacy and security of generative NLP models. So in a series of screenshots shared by Kevin Liu on Twitter, the new ChatGPT-powered Bing shared some confidential information which are hidden from the users. And this researcher managed to obtain those information after using a prompt injection attack that fooled the AI. Okay, included in those information is some instruction for the introduction and an internal name for this model called Sydney, and some language support and some behavior instructions that people, those companies use to tune those models. And although ChatGPT has already a large amount of common sense, but it could still make some elementary errors of common sense. And these language models are still not good at inference. But because the model is quite new, and there are a lot of research on designing proper prompts of using chain of thought to train those models and learn inference from the input data. The OpenAI, defined many internal policy and guidelines to address those ethical issues and bias issues. So, for example, ChatGPT doesn't favor any political group, but like many other generative AI models, may also, generate a biased result where the bias may come from maybe the language it trained from, right? And another concern is that OpenAI didn't actually release their policy and guideline that they use to tune the ChatGPT model, which may create another layer of concerns on the transparency of such AI models. And another big problem with ChatGPT is that it doesn't have a concept of what is saying true, and a lack of the ability to provide a reference for the fact. So this fact reference could be critical for clinical decision support and clinical research. If we want to know, where is the information come from. Okay, so at the end, I want to thank everybody in my team and also the funding agencies to support the research in my team. And thank you. I have 10 minutes for question Q&A.
Xiaoxi,
Okay,
I think there's a lot of
yourself.
questions in the chat.
I think there are mostly comments and very interesting comments. So Carrie said you can ask follow-up questions to ChatGPT about possible drug interactions, and you can also ask it to explain 8th grade reading level for communicating information to patients. And Wang made a comment in terms of it is possible to run through Microsoft Cloud with a BAA in HIPAA compliant manner with the right paperwork, and he has colleagues using GPT in this way.
Right, that's an important question that I think it's worth talking about. This is Brian.
Hi, Brian.
Hi, good, nice job. I was we had dinner with my CIO last night here at Michigan, and of course that's what we're trying to accomplish in setting it up. My guess is that it's going to be quite possible. The one thing that I'm curious about that came up in the dinner is that we got to go back to the consent for the use of the data to do the training in the first place. We have an opt-in system at Michigan. Because we're an academic health center, but I've got the lawyers looking at whether the use of their patient data and things like that could be used for the training purposes, specifically, I think is an issue and likely going to be a sticking point.
Yeah, I agree. So in clinical domain, it is because the sensitive data, it could be an issue. And another thing is I think for research, if you so that is actually based on how we want to share those generative AI models, right? So for example, you fine tune the model using your local data and figure out the model can do good for general humans. Do you want to share the data, or is there any legal issue if you share the data, right? So I think there are a lot of concerns and a lot of regulation issues around that as well. And again, that require leadership support, and particularly in the traditional healthcare sector.
You bet. We've got the Office of General Counsel here at Michigan looking at all the terms of use agreements straight up and down through the API and the service and our current status with the BAA. But we also put it on the agenda to look at that. So this is a good conversation. I wonder if I can ask just Brahmer, is it okay if I ask one more question, Brahmerji?
Yeah, of course, Brian.
Yeah, I'm just switching around to more of the academic and training front, and congratulations for your nice career start over there in Pittsburgh. It's amazing how transformational and how disruptive this technology is, especially in your area. And got students who are working on this and working on that, and you show some good examples there, but all of a sudden, frankly, this large language model system and the dramatic improvements we're going to see with the increasing number of features and more training is going to is remaking your field, and you showed that, I think, quite effectively through your talk. Mm-hmm. And so, what is the future for your students, their thesis research, your own work? How does that's going to change everything? And I'm wondering, you've obviously been thinking a lot about that, so it'd be very valuable to hear what you had to say.
Yes, for my students starting this semester, I add a slide in my course that if you ask a student, if you use ChatGPT, please put a citation there. So there's no university policy, how they can use ChatGPT. But honestly, I put all my assignment question in ChatGPT and it could generate the correct answer. So my course is about, statistics and programming in Python and R. And ChatGPT could generate correct programming code for my assignment. So I don't know how to deal with that issue. So we cannot, tell students because those tools are out there, right? We cannot tell students you cannot use those tools, but I just can tell them, okay, you can use them, but you need to cite them. And I think maybe someday they think the tool is better than me, and then they just stop enrolling our program, right? And there are a lot of panic in my domain as well. So particularly in academia. So every token generated by OpenAI, we need to pay 0.02 or $0.002 for every token it generates, so every word. So I feel hard to convince NIH, to give me some resource for this kind of, token generation, right? So I don't know how other people can convince NIH to give us. And without, those, so in my lab, we have a very powerful, already, I think a relatively powerful GPU, like for A100, and each one has a 16 gigabyte, and still it's not enough to train the large language models. right? So, and again, OpenAI, they didn't release GPT-3 and those the model behind ChatGPT, right? So, so for academia, I think for NLP researcher, definitely there is a panic because we label ourselves as an information extraction expert. We label ourselves as a question answering expert. Now everybody needs to become a prompt expert, right? And for academia, the lack of computing sources and the lack of, and those big companies control those resources, control those computing power, right? So it is, I'm not clear how the research, will go forward in our field.
Yeah, no, that was comprehensive across a lot. And in terms of the programming, early on, I downloaded several problem sets from our bioinformatics coding courses and core course into it with Python. It generated perfect Python code.
Mm-hmm.
And I decided we had faculty meetings and discussed it, and I encouraged everybody to build off of it. We've had broader discussions across with leaders here at the university. We're going to have to, I was just on the Zoom with the CEO of a tech company that's introduced chat into their AI learning platform, and it'll be released on Monday. And she told me that their coding, the burden of coding with the use of the chatbot has decreased by 95%. And so what I told the professors is programming and algorithmics is one thing, coding is another. We're not teaching coding anymore. Yeah. ChatGPT and GPT-3 and open, Copilot and these kind of things will do the coding. Teach how to use those tools. You teach programming, you teach algorithmics. And I think it would have to be that way.
Yeah,
thank you for the comment.
Can I ask one last question just to build on what Brian said? You mentioned this, I've seen this like just to hit us in waves, but I have to admit, prompt engineer was the first time I've heard that term or seen it. I'm kind of curious, is that like, what did you, like, is that literally what NLP experts are going to become? Is it technical? Is it more of an art? I just hadn't heard that term before.
So it is very new because, ChatGPT. So there are a lot of prompt engineer positions already on the job market. So I think, those traditional methods, they will not disappear. They will still be there. And we have to realize, understand the limitations of the current, GPT models and the strengths of those traditional models, like those rule-based NLP models. We are still using that, and those are, those approach are already embedded in the clinical infrastructure in many healthcare systems. So we have to continue to use that, but we have to realize that, we have to, make sure that we know those breakthrough technology are out there, and eventually, those techniques will unify all the different NLP tasks, and the field will shift from the old paradigm to the new paradigm. And I believe with the language model become more powerful, trained on more data, and every time you chat with ChatGPT, you are actually feeding data to ChatGPT, and you are teaching ChatGPT to, to become better, right? So with those large amount of user input, eventually those AI, AI model, GPT model will become very powerful, and maybe eventually, we will shift to those larger language models and replace those existing, pipeline and models. And also, for general people like domain expert, it is a good thing because previously they need to work with NLP experts to design model for their problem. Right now, they can directly interact with GPT. So maybe they need our help when we become a prompt engineer.
Thank you.
Okay.
Yeah, thanks, Yanshan. This is great. It's just so much information.
Thank you for having me. And my email is here, so if you have any questions or any idea, feel free to email me.
Okay, thanks, everyone.
Thank you.